Hi guys, this is Mani and then. So welcome to Creative Ideas Triple E. So today we are going to explain about footprint for NE225 IC. So I am going to explain about three variant type of footprint creation. Before creating the footprint, we must be know that pad design. So I am going to pad design software and I am going to select the STM sorry SMD and unit will be mm rectangle. So there is no drill for this SMD because we are designing the SMD component and we go for the design layer, choose the rectangle and width and height we have to be take from the data sheet. So you can see here height will be 0.6 and width will be 1.5. 0.6, 1.5. Next we have to go for the mask layer. So in this section we have to be select a few more details which will be available here is rectangle solder mask top and face mask top. So solder mask should be uh, more than this, little more as per the IPC standard we have to be go. So to be creating the solder mask we have to be see in the data source whether they have been mentioned or not. Yeah, they have mentioned here. So extra 0.03 we must be increased. Okay, and go for the face mask. Okay, done. And give some name which available in data sheet. Save it. Done. So once the pad design is completed, we have to be go for the Allegro. Here we have to be make a new folder like new project and here I'm giving NE555 and I'm selecting package symbol. So here we have to be know the all the package types. So now we are going to use the SOIC package. So now I'm creating the automatic footprint creation. So first steps, okay, make it millimeter and how much pin is available in IC according to dataset. So approximately 8 pin, give 8 pin, and lead pitch is, which will be center of the pin distance, one pin and other pin distance according to data sheet 1.27. Yeah, and terminal row spacing, which will be available in here 5.4, 5.4, and coming into package width and length. We should not be see the pad dimension. We have to be go for the package dimension. So this is what package dimension. So height will be here, they have been mentioned, and width will be dimensioned here. So as of now I am going to take maximum value of height and width. Height will be 5, 5, and width will be according to data sheet 3.98, 3.98. That's all. So go to next and select the pad which we have created previously. So the pad name is SOIC. Yes. Okay. Next. Next. Finish. To visible your pins properly, we have to go to setup, design parameter, and all the checkbox should be tick. Apply. Okay. If you want to be ensure whether the footprint is properly made by software, you click on the measurement and check between two pins. So the software says 1.27 mm. According to datasheet, we have to be compare it. Yes, 1.27 is there. So this is what automatic footprint creation. Okay. So now we are going to create same package but different type of variant type of footprints. Go to new and file. Yes, I don't want, and package symbol, give same in E555, in E555 G. Done. So you have to be ensure that the design parameter should be mm. Yes, give OK. And we have to be do according to data sheet. So you have to be ensure what is the distance between two pins. So 1.27 is the distance between pin, and 5.7 is the package width. So according to this data set, we have to be play with the grid. Go here. I'm giving y values is 1.27, which will be available in datasheet, and distance between from this 4 pin to this 4 pin is 5.4, 5.4, 1 point 5.4, 1.27. To reassemble the origin, you have to go to setup and change the drawing origin. You can select wherever you want and go to the add pin icon, click there. You will get patch stock, browse it, type it same pad design, click, select. You have to be choose the where the origin is there. There you have to be place first pin, second pin, third pin, fourth pin. Then go for the fifth pin, sixth, seventh, eighth. Right click, done. The pin placement is completed. Now you have to be change the grid 0.01, 0.01, 0.01. Done. If you want to be verify the pins distance and height, go to the measurement pin and click on here and here 1.27. You can verify 1.27 with the data sheet. Right click, done. Now we have to go for the assembling diagrams, which will be we will consider as package. So the package width and height is given here, height and width. According to this, we have to create the assembly diagram. So for that I am going to choose the rectangle type and rectangle place, width value I am given, height value given here. So you have to be keep properly. That's all. Once you place the assembly top, right click, done. So you have to be ensure properly you have been placed or not. So now next things will be we have to be create the place bound top and DFA package as well as shell script. Now I am going to create the place bound top here. Select the package geometry because we are creating the package, not in board geometry. Package geometry we are creating, like this is package, right? And we have to go to select the place bound top and same things you should not be place it here. A little more should be required according to data sheet. which will be available here, like width is 6.19 and the height will be 5. So according to this you have to be create the place bound top. So already we have been mentioned 5 here, and width will be increased according to datasheet 6.19. 6.19. So this you must be place it here. That's all. Right click, done. Now we have to be create for this package DFA, design for assembly. So for that we have to be create according to data sheet, like you can see here 5.4 and height will be same, like 5 mm only, and 5.4 is there between two pins distance. So in this scenario what we have to be cover, so it's like a 5.4 plus the pad with 1.55, which will be there here, and you have to be increase 1 mm. So the total will come approximately 7.95. So go to here, click on the rectangle, go to DFA bound top and place here 7.95. That's it. Okay. Now you have to be create the silk screen. So before the silk screen creation, you should not be go for the rectangle type, because the silk screen should be visible in the PCB board. So for that I can recommend it for this line to be visible properly in the PCB board. So click on the line and select the silk screen top. The line width will be according to IPC 7351 0.1016 line width, and create the line after the DFA. To identify the first pin, we are making this slide here. That's all. So almost our footprint is completed by using grid values, and you have to be mention, or you have to be keep align the pins. Move button and find of the all things, and only the text should be on. Keep near to the pins. Okay, so once this is completed, so once this is complete, we have to be ensure, we have to be create the labels like reference designation for the assembly as well as cell screen. Click on here, give some name to this IC, right click, done. Similarly, you have to be give for the cell screen top, right click, done. So that's all. Our footprint is completed according to grid value. So now we are going to create the, by using command export, we are going to create the footprint. Okay, same like I don't want NE 555C. Okay, make sure where your origin is there and click on the grid. Okay, check it whether is there or not. Keep the value will be 0.01. Similarly for the X and Y. Okay, now we have to bring our pin by using this button. Same package we have to be take it out. Yes, this is the package, and go to the command section and click here, and they give the command like X space 0, enter. To keep proper origin here, we have to give a command to place the first bit, X space 0 space Y space 0, enter. Okay, so first pin is be placed here, and second pin we have to be placed according to your data sheet. So data sheet is saying that 1.25 distance should be made. So according to that we have to be write the program here, or else write the command here. Okay, now we have to be placed second pin as well. So for that command we have to give here x space 0 space y space minus 1.27, enter. Okay, so second pin is placed here according to our data sheet. So now we have to be place the third pin. So how we can place? So consider 1.27 1.27 is the one pin to other pin distance. If you compare, like if you want to be add other pin as well, you have to be give 1.27 extra. Okay, so example, from this pin to this pin 1.27, if you are considering, then what about third pin? So third pin distance will be approximately 2.54. Okay, so that command we have to give x space 0 space y space minus 2.54, enter. So completed 3 pins. And if you want to be same process, if you want to be make a fourth pin, you add 1.27, so it will come approximately 3.81. So give x space 0 space y space 3.81, enter. Sorry, x space 0 space y space minus 3.81 space, enter. Completed, right? So 4 pin is, we can see here 4 pin is available. So right click, done. So 4 pin is according to data sheet we have been placed here by using command. Okay, to be placed the fifth pin we have to be give command here is like x space 5.4 space y space minus 3.81 space, enter. Completed. Now what we have to give is here similarly x space 5.4 space y minus 2.54 space, enter. And next section y space 5.4 space y space minus 1.27 space, enter. Okay, and at last pin we have to give is save x space 5.4 space y space minus 1 point sorry 1 point no space minus 0. Yeah, completed. So right click, done. So by using command we have been placed the 8 pin here. Okay, now we will check it whether it is there as per the datasheet. 1.27 is correct according to datasheet. Yes, yes, and we have to be checked with this pad to other pad. Repeat one pin and 8 pin 5.4. Yes, 5.4. And that's all. Now we have to create according to the package geometry and place rectangle, and you must be know the package of your component. 3.9 height will be 5, height will be 5, 3 3.98 is correct. 3.98, yeah. So now we have to keep according to placement type. Right click and now you have to be placed the place bound top according to datasheet, and for the place bound top is which will be little more 6.19. So where it is 6.19, 6.19, you have to choose the place bound top and keep that's right click that. Now we have to be select for the what is DFA. So choose the DFA bound top, go to check the pad distance here. So pad distance will be 5.4 plus 1.5 plus 1, 7.95. So 7.95, 95. So keep properly. Done. Right click, done. Now you create a line width 0.1, close space. Or else what you can do is uh, you can create more than this. It's approximately extra, make it 2 mm, 7 is there, make it 9, this you make it 7. No, this is too much. Give 7, 8 and give here for 1 mm extra. Sorry, decrease the 1 mm. Perfect. right click that. So yeah, now what you can do is click on here and mention the 0.1 mm and start to create the full line silk screen because it will be easy to draw the things. Okay, okay, and here make it little slide to identify the first pin. Right click that. So completed. Now what you have to do is you have to delete the previous one silk screen that. And we have to be make alignment of pin text, keep properly near to the pin. That's it. Right click done. To be we have to make the labeling. You right click done and label again for the assembly, sorry, silk screen top. Click you, right click and should be move that. That's all. Right click complete. So that's all the footprint creation. So thank you for watching this video. We will meet you next classes for the through hole footprint. Thank you.